Hello and welcome to yet another video of Cornerstones of Math. Today I got this nice little geometry problem which looks simple, but not as simple as it looks. You have to do some work here. So the problem is, for a circle with diameter 8, two chords A, B, and C, D intersect perpendicularly at point P. Given that the length of line segment PC is 2 and the length of line segment PD is 4, what is the length of AD, denoted as x in the figure? This problem will be solved by two methods, which I am very excited about. Especially one method is by pure geometry, and the other is by coordinate geometry. In pure geometry method, we are going to use several important geometry theorems, which you might have learned in pre-college math. And in coordinate geometry method, we will be solving a lot of algebraic equations, because that's essentially what coordinate geometry is about, turning a geometry problem into an algebra problem. So let's get on with pure geometry method first. For simplicity, let us denote length PA, PB, PC, and PD as lowercase letters a, b, c, and d respectively. A and b are unknowns, while values of c and d are given in the problem. The value of x can be calculated if we find the value of a. First, we can apply the all-time famous power theorem of circles. Using our notation, the formula is simply a times b equals c times d, which gives ab equals 2 times 4, hence 8. So this is the first equation. We need one more equation, and to obtain that equation, we must take this diameter of the circle into account. So let's draw some additional lines. First, let's draw a chord BE that is parallel to chord CD, hence perpendicular to chord AB. Then, if we connect points A and E to construct triangle ABE, it is a right triangle, meaning that AE is the diameter of the circle, which I will denote as italic capital letter D. And the value of the diameter is given as 8 in the problem. To use this diameter, let us try to find the length of the chord BE. The diameter AE passes through the center of the circle, point O. Let us draw a feet of perpendicular from center O onto both chords CD and BE, which can be done by a single line since two chords are parallel. The feet on chords CD and BE are named F and G respectively. You might have proved in basic geometry class that the perpendicular drawn from the center of the circle to the chord is the perpendicular bisector of that chord. That is, since point F is the midpoint of chord CD, length CF is equal to half the length of chord CD, hence C plus D over 2. Then what would be the length of PF? Well, this length is length CF minus length CP, hence C plus D over 2 minus C, which gives D minus C over 2. This means that length of BG is also D minus C over 2, and since G is the midpoint of the chord BE, length BE is twice the length of BG, hence it is D minus C. Therefore, if we apply the Pythagorean theorem on the right triangle ABE, length AB is A plus B, so A plus B squared, plus length BE is D minus C, so D minus C squared is equal to AE, the diameter squared. The length of diameter is 8, so we have 64. From the given values of D and C, we know that D minus C is equal to 2, so A plus B squared is equal to 64 minus 2 squared, hence 60. So we have A plus B equals positive root of 60, which can be also written as 2 times square root of 15. And this is our second equation. By the way, using the above Pythagorean relation and the power theorem AB equals CD, you can obtain this neat-looking formula for the diameter of the circle, which is applicable when two chords used in the calculation are perpendicularly intersecting. Anyway, back to the problem. We obtained that the sum a plus b is equal to 2 times square root of 15 and the product ab is equal to 8, and now it's time for some algebra. If you have learned the Vieta's formulas or the relation between roots and coefficients of an equation, you would immediately want to use the fact that a and b are two roots of the quadratic equation t squared minus sum 2 square root of 15t plus the product 8 equals 0. Solving this gives the values of a and b. We need a to find the length x, and since a is greater than b, we take plus sign from the quadratic formula, so we have a equals 2 square root of 15, then plus square root of 2 square root of 15 squared, and let's write it as 4 times 15. Then we have minus 4 times 8 divided by 2. Here we can divide numerator and denominator by 2. We just have to cancel this 4 from the inner radical. So the denominator becomes 1 and we have square root of 15 plus square root of 15 minus 8. Hence we have square root of 15 plus square root of 7. Therefore, x, the length of AD, is given as square root of a squared plus 4 squared. So we have square root of 15 plus square root of 7 squared plus 4 squared, which gives square root of, the first square gives 15 plus 7 plus 2 times square root of 15 times 7. Then we have 4 squared, hence 16. So we have square root of 38 plus 2 times square root of 105. We can actually denest this using the following denesting formula, which is applicable when the inside of the outermost radical is in x plus y plus or minus 2 times square root of xy form. Notice that 105 equals 3 times 5 times 7, hence it is 35 times 3, and 38 equals 35 plus 3. This means that the inner part is square root of 35 plus square root of 3 squared, hence x is equal to square root of 35 plus square root of 3. And this is our final beautiful answer. However, this is not the only way to solve the problem. The thing is, this problem has another fancy way of solving it, namely the coordinate geometry. When it comes to coordinate geometry, the first important step is to nicely set up the coordinate system, that is x and y axis. And considering that we have two chords that are perpendicularly intersecting, it will be beneficial if we let lines CD and AB as x and y axis respectively. Hence the intersection point P becomes the origin 0, 0. We also need coordinates for the center of the circle, so let P, Q be the center of the circle. Then the equation of the circle is x minus p squared plus y minus q squared equals, the radius of the circle is 4, hence 16. We have to find the values of unknowns p and q, hence we require two equations. Such two equations can be obtained by using the fact that point C, which is 2, 0, and point D, which is negative 4, 0, are on the circle. So using point C, we have 2 minus p squared plus q squared equals 16. And using point D, we have negative 4 minus p squared plus q squared equals 16. So now we have the system of quadratic equations on P and Q. Actually, this is the system of quadratic equations that is quite easy to solve. Because if we subtract second equation from the first equation, it just straight up eliminates one of the unknowns Q. Then all we have is 2 minus p squared minus negative 4 minus p squared equals 0. So by expanding, we have p squared minus 4p plus 4 minus p squared minus 8p minus 16 equals 0. So p squared term gets cancelled, and you can easily find that p is equal to negative 1. And substituting this into equation 1, we have 3 squared plus q squared equals 16. So q squared equals 7. Here, q is positive because length PA is greater than length PB, hence q equals positive square root of 7. With these values of p and q, the equation of the circle is x plus 1 squared plus y minus square root of 7 squared equals 16. And the coordinates of points A and B can be found by letting x equals 0 and finding the value of y, which gives 0 plus 1 squared plus y minus square root of 7 squared equals 16. So y minus square root of 7 squared equals 15. So y minus square root of 7 equals plus minus square root of 15. Hence y equals square root of 7 plus minus square root of 15. This means that the coordinates of point A is 0, square root of 15 plus square root of 7, and for B, 0, minus square root of 15 plus square root of 7. Here, notice that the y-coordinate of B is negative, as expected from the figure. Therefore, using coordinates of point A and point D, which is negative 4, 0, the length of AD is given as square root of 4 squared plus square root of 15 plus square root of 7 squared, which gives the same answer as the previous method. And that's all for today's video. Thank you for watching. Please don't forget to hit that like button if you enjoyed this video, and I will see you in another video.